I'm going to show a quick PowerPoint presentation and then go to show ARCADY 8, show a quick demo of how to set up the lanes. So here we are, ARCADY 8's entry lane analysis. Okay. So what we're talking about here is roundabouts modelled in ARCADY where there's several lanes on each approach and examples of uneven lane usage. Historically, this has been something ARCADY's not been able to model particularly well. I'll show you some examples. So, simple case here, we've got a 3-arm roundabout and 2 lanes on arm C up here. And in this example, we've got far more left turners, as the orange vehicles here. Big movement there, turning left, and relatively small movement turning right. So different sets of flows, different turning proportions. So what happens here is the offside lane, that tends to be kind of on and off fairly empty. You can see it's not, there's blank space here, that's wasted. Difficulty in ARCADY is the model doesn't really know that, it's not aware of that because it's not had that level of detail in it. What happens is that ARCADY assumes traffic can actually kind of use both lanes spread across the whole arm. So, you know, red and orange vehicles just evenly split between the 2 lanes. ARCADY thinks the whole entry width, you know, could be 7 meters here, that's available for all the traffic, doesn't really discern between the left and right turners. So, as a result of that, what may happen is ARCADY can tend to overestimate the capacity. So the queues and delays you see when you're in ARCADY may be on the small side compared to what they actually would be in real life. So the big capitals here, that may happen. That's because in the original research back in the 1980s, there was some uneven lane usage. Some of that's implicit in the model, but it's not explicit. Another example here is where we've got the same roundabout, this time 2 lanes, 1 lane upstream widening to 1 lane plus a flare close to the roundabout. You see here at this instant in time there's a queue of red vehicles turning right, and that means the orange vehicles wanting to turn left, they can't get into the flare, okay? They're blocked from using it. So this is what we call entry starvation. It means although you've got a nice flare here, a lot of the time it's not actually able to be used. So again, you've got some wasted space there and potentially some wasted capacity. So queued right turners can't, blocking access to the flare. Flare's often empty. Obviously it depends on the turning proportions, capacity, or all the other properties. And again, ARCADY may overestimate the capacity. Again, some of this was in the original research, but it's not kind of explicitly taken out. Third example here, again, same roundabout, and this time we've got some actual lane markings painted on the road. So this could be actual directions, signs, physical paint on the road, or it could just be the lanes that people tend to use given this particular roundabout. So in this case, obviously you've got safety constraints and geometry and so on, but in this case you can see it's hardly any left turners. Red vehicles could use the other lane, if you imagine it was safe to do so, and they don't in this case because of the lane markings. And again, you have some potentially wasted space here. So it could be a choice of lane markings. How does ARCADY know which movements are allowed from each lane? The answer is, until now, it hasn't done. Basic ARCADY model just assumes all movements are allowed from each lane. In fact, it doesn't even know about the lanes at all. And again, this is another reason why it can overestimate capacity. Those were slightly artificial examples, but you can see here these real Google Map images. So, real roundabouts, one on the left. You can see there's a left turn lane, bit of hatching. Then you've got straight ahead and right lanes. Example on the right, again you've got 3 lanes at giveaway. This is actually a mini roundabout, I think. Quite unusual. And 2 lanes upstream. So you've got 2 lanes widening into 3 lanes. So neither of these examples could easily be modelled in ARCADY. This is one of the reasons why we've added this new feature, which has been present in ARCADY 8. What people have tried to do before, some cases this effect you can just ignore. Could be a small effect, so don't worry too much about it. But how do you know whether it matters or not? That's always been an issue. Another thing people sometimes do is they say, one lane's not used, so just don't model it at all, just remove it. That could work. You could apply inset corrections, and there are various ways of doing this. Again, that's subject to error, can be a bit simplistic. How do you know you've got it right? And that may be fine in simple cases, but what about the more complex ones? How do you know how to actually do this correction? It's actually quite hard to analyse this mathematically, partly because roundabout traffic arrives and departs randomly. Okay, so traffic arrives in kind of bursts. It's not kind of smooth, uniform like you've got a traffic light. You can have little patches where you have a lot of vehicles, then gaps where you have no vehicles for several seconds or minutes at a time. So it's quite sporadic. So what we've done is we've added a new simulation-based model which sits on top of the core ARCADY model. It's intended mostly as a tool, helps you see if lane usage is an issue in the first place, helps to compare different configurations in the kind of relative sense. One of the advantages is there's no particular limit to how complicated you make the lanes, so you can have any number of lanes feeding any other number of lanes. Just repeat there, this is basically an addition to the core ARCADY model, so it's an adaptation of the main model. Here are a couple of screenshots to see what it looks like. But I think it'd be easier if I close this down and actually go and have a look at it. So I've got Junctions 8 on the desktop. This is the current version, just released last few weeks, so 8.8.2. Okay, so ARCADY starts up, usual screen to that's what I want to do. So I'm going to say I have a roundabouts for standard roundabout. Be a good one to start with. Okay, news update, I can close that. So if you've used ARCADY 7 or ARCADY 8, this will obviously be very familiar with to you. Brand new file, default options. Let's have a look at the diagram. Okay, so nothing special here at all. In fact, I can just run the file because the default turning counts are present in a new file. To keep things simple, I'm just going to leave this all the same, leave the geometries on the default values, no need to touch those, and I can just run that. So, as you can see here, this is a very simple file, so I've got kind of very short queue in each arm. Doesn't really make a lot of sense. So to make it a bit more interesting, I'm just going to artificially put the flow scaling factor up to a much higher value, just so we have something to look at. So you can see a queue of about 40 PCU on each arm. Again, not a real junction, just so there's some numbers in here so that we have something to look at. So this is a normal ARCADY run, no lanes yet, just some simple arms. What I can do is turn on lanes. Okay, the first thing I need to do on this is turn on advanced mode. Something we introduced in ARCADY 8 just to kind of distinguish between basic things you might want to do for one-of-the-mill files versus like more advanced features. There's a preference to make this be on all the time. That's not turned on this computer just yet, so I'm going to manually say I want to go into advanced mode. Are you sure you want to switch? So, okay. As soon as I've done that, you'll see I've got a few more buttons down the left-hand side, a few more options and so on. One of those is called lanes. So I'm going to click on that. That gives me a warning about entry lane simulation can only be used, da-da-da. Would you like to turn this on now? I'll say yes. And what that does is bring up a new screen, which I'll come back to in a moment. close it for now. And you can also see the diagram looks a bit different. Each arm now has one lane on it. You can see this kind of this rectangular block on each arm. Quite a lot of kind of clutter and stuff on this screen at the moment. It's a fairly small window on this laptop, so I'm going to go to the options screen, turn off a few things that we don't really need. So turn off the IDs on there. I can turn off some of the other outputs just to clean it up a little bit, just for this demonstration. Okay, it's a little bit neater. So one of the things you'll see on each lane, we've got these turning arrows. They show which movements ARCADY thinks are allowed on each lane. Okay. So this lane here, this allows all movements by default. So you've got lefts, straights, rights, and also U-turn is this kind of thing here. Just to make it a bit easier, there's a couple of ways you can do this. I'm going to take off these U-turners because they confuse things slightly. There's a couple of tools you can use to do this. It's going to be quicker actually. Just turn them off in one go like this. Okay. Remember to put this one back on. Okay, so each lane has lefts, straights, and rights. No U-turners in this case. Turning counts are all the same, so I haven't changed those. Geometry is the same as before, so all I've really done is just taken the existing ARCADY arms and said there's one lane on each arm, which it would be kind of by default anyway. Now, when you're in lanes mode, there's a controlling screen which has a huge button here called Start Simulation. Okay, that's the same as just running the model. So let's see what happens when I click that. Okay, get an information message. I can just ignore this. Okay, and then as soon as I start to run, you'll see some results appear, exactly the same format as a normal ARCADY run. Summary results. I'll come back to those in a second. And you'll see some numbers up here changing fairly slowly. A thing called convergence, number of trials. After a few moments, this simulation will stop. See, the convergence reached 1%. All this is really telling you is it's running a large number of random trials, and it's an indication of how good it's got to giving you a good, accurate set of answers. Looking at the results, you'll see a Q on each arm. In this kind of artificial example, there's about 40 on each arm, which is pretty much the same number as we had a minute ago, because this just represents the same type of junction, all movements on each lane. Notice the Q is not exactly the same on each arm, so 40.02, 41.65, partially because there's some randomness in this simulation. These numbers won't be identical, there'll always be some variation. So if I run it again, for example, keep an eye on these numbers changing, you can see straight away they're kind of around 40. Leave it a bit longer, they'll get more similar to each other. But you don't actually need to wait for it to finish. I can just press the stop button, and you'll see the results are pretty much the same as what you would have had if you left it to finish. In other words, the result is the Q's about 40 on each arm. And you also get delay. If you look in the time segment results, you'll see same results as you would do for a normal run: circulating flow, start queue, end queue, delay, so on, so on. One of the extra things you can also do is have a look at what the simulation thinks has actually happened. So we've got a few different visualizations on the screen here. Let's have a look. Warning message, turn it off. So one of them, for example, I'll turn this one on here, individual vehicles. I've got a time slider here, which goes from whenever this file is set up to run, which I think will be 8 o'clock until 9 o'clock. Let's check that. Yeah, 8 till 9:30. Okay. what happens is I can drag this time slide, you'll see the diagram doing something. I'll stop it there. So this is it. So look at 8:30 a.m. Okay. So these coloured blocks in the diagram, these represent individual vehicles for one run of the simulation. Okay. Now in this example, I've got some very big queues. So what I'm going to do is change the scale. By default, it's 20 meters. I'm going to say it's more like 100 meters. Okay, so this same distance now represents 100 meters rather than 20 meters. And you see the coloured blocks have got smaller because I can now fit, well, and extend the arms a little bit as well. So I can now see more on the screen. And then the different colours here. So if I look on arm 3, got some green vehicles up front. That just means they're headed towards the green arm, which in this case is arm 2. So they're the right turners. Similarly, arm 1 is coloured in red here. So any red vehicles, other ones headed straight on in this case to arm 1. And you can see they're kind of randomly mixed up. Sometimes there's a bunch of red vehicles here, a bunch of yellow, but it's fairly random. If I leave that to animate, then you can if you look closely, you can actually see the vehicles kind of moving along kind of in a fairly jerky way, but you can actually see them working their way down the lane. When they get to the giveaway line, the ARCADY model comes into play. They'll have a certain capacity, then they'll either go or they'll wait at the giveaway line. That's what causes the queues, you see. If I look at a particular moment, so I look at just randomly 8:33, okay. So this instant in time, this happens just by chance to be a much bigger queue on arm 3 than there is on this arm up here, for example. That in itself doesn't really mean anything. That's just a bit of randomness coming in. This would happen in real life at a real roundabout. If you did multiple runs, you would see eventually they kind of cancel out. That's what you see in the main results. This is basically many, many thousands of runs behind the scenes, kind of averaged out to give you an average set of results. And you'll also see that if you look at this other visualization here, which is the average queues. Again, color-coded. Positions don't really mean anything, but this is showing you there's a queue of straight-ahead vehicles, there's a queue of right-turning vehicles, and they're about the same length as each other, so they're all about the same on average. Another mode you can do is use this shading, with shaded percentile queues. And what this means is the darker the shaded blue, the more likely the queue is to reach to that point. So you can see right back here at, let's get the scale. I believe this is to scale. So right back over here at what we got. You know, in this case it's ridiculous because back at 180 meters from the junction, still some blue shading here. So there's a definite chance the queue could be that long. You can look in more detail on this. This is because this is a simulation, so we can get lots of statistics and information about this, even if you only have one lane on each arm. So this is still quite useful. So I can say, for example, give me the 75th percentile queue, which it's now done. And let's do that for the busiest time of day, which I'm going to guess is somewhere around 2/3 through the peaks, maybe 9 o'clock. Then what you can do is use the scale. So in this case, very overloaded junction indeed. So I've measured this distance to be about, well, getting on 300 meters, and it's saying there's a 25% chance the queue could be longer than that on any given day. So as well as modelling the lanes themselves, it actually gives you some feedback about the relative likelihood of different queue lengths. And you can interpret that to mean there's that similar potential for delay being above a certain value as well. Okay, so let's turn that off and take these back. make it slightly more interesting by this time let's have 2 lanes. Now this hasn't changed the actual width or any other geometries, so I've still got the same arm width. All I've really done is kind of split that width into 2 lanes. And at this point, I can say that, for example, the left-hand lane only allows lefts and straights in that lane. And similarly, the offside lane doesn't allow left turners. In fact, let's go a bit further and say that's, what should we do? If you say the offside lane is for right turners only in this case. So this could be real lane assignments. These could be painted on the road. They could be via signs, or it could just be what you think people will typically do at this roundabout. The important thing is it represents what ARCADY is going to model. So start the simulation again. I could sit and wait for it to finish, but there's no real need because I can see the answers pretty much straight away, so I can stop it. Okay, look in the summary results, and you'll see the Qs on most of the arms are again around about 40-ish. Q on arm 1 is much bigger. Delay is enormous as well. So this is the same turning movements. I haven't touched those. Same geometries. All I've done is kind of split the movements. And at this point, you can look at the visualization, individual vehicles. I can play this. Doesn't really add a lot, but with it. In here, but they don't really form. Previously, in effect, all the arms were set up to have all movements everywhere. That's pretty much all you could do in ARCADY. So obviously this is pretty powerful. You can set up, let's turn this on for a moment. So for example, you could have 3 lanes. Say the central lane goes straight ahead only. See if this works. And then upstream from that, let's see what I've done here. Oops. Try again. And then give a slight tweak. So what I've got now is at the upstream end, single lane with all movements, and then that widens into 2 lanes at the give way. Foreigners at the moment, this will hopefully give me an error because I think let's have a look. No, didn't in this case. I was expecting it to tell me I've not put a left movement on here. Let's do that anyway. I think it would normally do that straight away, so I'll check out that. Let's run the simulation anyway. And this time you'll see, again, I've not changed the turning counts or the flows, or the geometry indeed, but just by splitting the traffic into lanes like this, I've got different queues and delays, so the whole performance of the roundabout has changed. And again, you can look at the detailed results or the numerical results. You can run a report, see all this. or you can see visually here where the vehicles actually are. You can see straight away in this case, but pretty much most of the time, this offside lane here is hardly being used because people can't access it. Again, just due to the lane assignment. That's the basics, and just to briefly finish off, let's have a look. So, for example, there was a picture I had in the PowerPoint. So in ARCADY you can have a background image on the diagram. We can, let's just fade that down a little bit. So this is set up to look like a PowerPoint example. Bring up the lanes, the screen, run this. Again, you'll see the convergence. Some users at the moment do kind of sit and wait for this to go all the way down to 1%, which can take a while in some cases. But again, if you can see the results, I can see instantly there's a much far bigger queue on ARM 3 than the other two, so I don't need to sit and wait for it to finish. I can just stop it. All that will happen if you wait longer is those results will get, in theory, slightly more accurate. So you can see in this case, I think we set it up to have only left turners in the left-hand lane. You can see a huge queue in here, and then wasted space in the other lane. And in theory, you can set up more complicated examples, no particular limit to how many lanes or how many the ways of movements.